My name is Zach Skelko, as Brandon just gave me a pretty thorough introduction. I'm just going to jump right into it. If you want to follow along with the slides, you can certainly clone the repo yarn and yarn run start. It's actually just a React application. So kind of give an overview of what we're going to do here tonight, and that is talk about the event loop, which is, of course, the main stack. Web API is the callback queue. How to optimize to prevent thread blocking, and obviously finding out what thread blocking is, and multi-threading, which I'll get into. That's why there are more than one slide. So if you don't come from a computer science background, you might be thinking, what is any of that I just said? And so when you first look to JavaScript, if you look it up, you find out it's single-threaded, right? So what does single-threaded mean, especially in the context of JavaScript? And I think the easiest way to describe what single-threaded is to describe what multi-threaded is and how JavaScript isn't that. So we look at a multi-threaded operation. These two lines each represent a thread that functions can add memory operations onto. So function A will add operations onto it, and function B will add operations onto that. And you'll find, once those operations are all added, I should have recorded a shorter demonstration video, but those operations don't execute necessarily in the order that they were added to their thread, or to the environment as a whole. They do execute in order that they were added to the thread, however. So I need some audience participation. I need someone to be my first function. Come on up. And I need a second function. Okay. So,
I guess I'm an orange function.
Yep. So I'm single-threaded, which means that I can only operate on one thing at a time. So function B has passed me an operation, and I do it. And function A has passed me an operation, and I do it. And function B has passed me an operation, and I do it. So if I was multi-threaded, what could I do? Now, if function B hands an operation to, and I did that one first, and then this one happens, and then this happens, and then, oh, OK. So you notice that the operations are not happening in the order that they're being received. So the difference is that JavaScript handles those operations in the order that they're received, which, thank you guys, is great for some things. It's easier to debug. It's more logical to write. The order that you put your code on the screen is the order that it's going to execute. Now, what I don't have is why single-threaded is bad. We'll get to that after we go a little bit over what the stack is. So stack, for those with a computer science background, you obviously know what that is. For those of you who don't, which I think is a lot of the community here, which is actually what I like a lot about this community, I am a self-taught person myself, and coming to a lot of this as a novice, this, for a time, didn't make any sense to me. But a stack has two operations. You can push things on top of it, and you can pop things off of it. Those are the only two things you can do with a stack. And the stack works the same way in JavaScript. So I need 3 volunteers this time. Just come up, yeah. Your foo? Bar.
All right.
And Baz. And we have our stack. So the first operation that's called is console log, and I'm going to give that one to free as myself. So the first thing that I do is I call foo. So foo, you'll put an operation into the stack. And foo calls bar, and bar puts an operation into the stack. And bar calls baz and puts an operation into the stack. Now the way this works, so we pushed all those operations onto the stack, and we can pop them off in order. Baz, bar, foo. So they go on in the opposite order of how they were added. Great. Now what happens if we do a recursive function? In this case, foo. We call you once, foo. And foo gets called again. 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 And again. And again. Yeah, and again. And, oh, it is an overflow. That is a stack overflow. That is literally what it means, is that you have pushed too many operations onto the stack than can be operated on. Thanks, guys. And as you can see here with the actual counter, this goes forever, right? There's no default case where this is going to end. Now, that's a contrived example. And what presentation would be complete without several contrived examples? Most things in D&D happen when you roll a 20-sided die to determine if you can do a thing. A roll of 20 is a critical success. With disadvantage, you must roll two 20-sided dice and take the lesser result. Okay, simple, two simple rules. Now, your party comes upon a sleeping giant. You can do nothing to wake him. No, nothing. He's very asleep, and you are very tiny compared to him. You must roll a critical success to move him away from the entrance to the cave, which is where you want to go, right? So, I'm just going to put my phone in airplane mode for a moment, because somebody continues to try and call me. Sorry. So, something we might want to do, if we need to, there's nothing we can do to wake this giant up. We're going to roll and roll and roll and roll and roll and roll and roll until we get a 20, right? Now this would be very boring if I was actually a player playing this game, but since I'm a function, I can do this all very quickly. And I'm going to now, this function that I've described here is synchronous. It's going to run and run and run and run until it receives a roll that's 20. So we're going to roll. We rolled. In 2 rolls, we got a critical. Great. In 56 rolls, we got a critical. Not so great. Now, what if we had disadvantage? Which means we take the lower of 2 rolls every time. Okay, it took 92 rolls. Now what if we had this fake double disadvantage where we actually roll 4 dice, which doesn't actually exist in the game, so please nobody at me. And I'm going to roll. And I noticed something different immediately, is that my button stays red. My browser can't even repaint because it's still doing this synchronous operation. It can't unactive my button. And I'm pretty sure that we'll get there eventually. But so what's happening is we're thread blocking, right? We can't move forward in our operation. And part of that operation for JavaScript is to repaint the browser. Without being able to repaint, we can't say, I've stopped clicking this button. And Somebody added me. Okay. So I can't even stop this. I can't even run away. I can't say I want to stop this operation. None of my clicks are getting listened to now. This is a horrible user experience. I can't even pull down my select at this point, and we've rolled 25,000 times. Okay, great. I can't even close my browser. Great. This is awful. Okay. So thankfully, Chrome is going to stop running that because the window is no longer in focus. Now, nope, it's not going to stop running it. Yes, please end the task. Yes, and now. Yep. So this is obviously something that you don't want your user to experience, right? No, please don't restore the pages because I like to continue the presentation actually. So, no, it's not running because I didn't. Yeah, but anyway. So great. This is thread blocking. It prevents the rest of your code from executing. It prevents the browser from repainting. It prevents all sorts of things. Now, there's some real world candidates for thread blocking. Something that, like, you would not be doing a while loop trying to roll a 20 when you could just write a function that returns 20, right? So some real world candidates that could happen, a complex geometric computation, image processing, if you're actually cycling over all the pixels in an image, in a large image, like say something that somebody captured with a camera. Yeah, exactly, an image. Recursive DOM exploration and modification. This is actually why React uses and Vue use something called the shadow DOM, which they run diffs on their own, not actual DOM, so they don't manipulate the actual browser, because those repaints can actually block the thread. And then computation on user events. So for instance, scroll events fire constantly. Like if you should be throttling any reaction that you do to a scroll event. But I thought JavaScript was asynchronous, right? So it is, right? Because you don't actually go down your code. Like you use something like, hey, I'm adding an event listener to a button. I click it. I'm supposed to do that. That's going to jump around in my code, right? Well, it is, but your stack has to be processed first, right? So if there's something in your stack, your callback queue can't work. Your callback queue is what, exactly that. Callbacks get added to. So while that while loop was going, the stack kept going up and up and up and up, and we kept taking one off and adding one on and taking one off and adding one on. And we couldn't process the callback queue, which is where my click event listened. When I clicked run away, couldn't run away. So once the stack is cleared, the callback queue can clear, and we can move on. So I'm going to need a couple more audience people. Just 2 this time. All right? All right. Okay, so you're going to be the event loop. So the event loop can do one thing. Well, 2 things, but it can only do it one at a time. It can either take something off the stack or take something out of the callback queue. Just kind of went over this, but for a visual demonstration, you're going to be the callback queue. And I'm going to be the main thread. So I'm adding something to the main thread, and then somebody clicked something. So if I click something, we're going to add it to the queue, right? Now, go ahead and take that next event off of there. Go ahead and put that in. So it's a queue, right? It's different than a stack. The stack is going to process from the top, and the queue is going to process from the bottom. So there's nothing left in the stack here. The event loop is now free to take something from the stack, or from the queue, excuse me. Okay. Makes sense, right? Right, okay. Thanks, guys. But now, this is called the callback queue. How do I add something to the callback queue? Can I add it with, okay, I can write a closure and I can do some, or I can write a callback, right? I can write a recursive function. That should add it to the callback queue. That's what it's called. I should be able to call that. Well, no. I'm going to open this. So recursive rolling under normal circumstances, you know what? We're going to open just another browser. Okay, we're not. Recursive rolling should add into the callback queue. Well, it doesn't. The callback queue is for something very specific, and that is shit. Got very good at this when I was writing all these demos, so callback queue is for something very specific. It's not for callbacks that you necessarily write. It's for callbacks to please. To web APIs. Because no, that's not going to work. JavaScript is still single-threaded. You're still in the context of JavaScript. Your callbacks that you write still get added onto that stack the same way that if you wrote every line of code one for one. So we talked about what the event loop can do. If there's something on the stack, it takes from there, and if the stack is empty, it checks the callback queue. If the callback queue is empty, it does nothing, which is idle, which is great for your next operation. But how do I get things into the callback queue? And that's web APIs, right? And if you're actually from Node, this kind of works the same way with like their C++ tie-ins. But wait, what the heck are web APIs here? So a lot of the actual methods on the window object are actually web APIs. Things like set timeout, request animation frame, and XHR requests. These are not actually part of JavaScript. They're not part of the JavaScript language. If you look at the V8 engine's code, that's not referenced in any way. What they are is tie-ins to your browser. And your browser is the only thing that can add things to the callback queue. So in this case, we're going to set timeout 0. You've probably all done this before, and you've probably wondered, why the heck do I have to do this? I should. And what you're guaranteeing by setting set timeout 0 on your loop is that everything in the stack has been processed. And when that stack is empty, I can go ahead and do this. So you should know that set timeout isn't like a guaranteed time to execution. It is a minimum time to execution. That is, if there's nothing in your stack, it will execute in that amount of time that you set. If there is, it's going to process that whole stack and then count up to your timeout. So you can do the same thing with either a set timeout or a set interval. It's the same, and this time, I promise, it will not break. We're going to set interval. OK, great. I was able to. OK, it's going to run. it's running, it's trying to, but I can run away. Look, my browser was able to repaint. I was able to insert a new operation while staying inside the context of that loop. Now, this is not great. Obviously, you don't want to be throwing around set intervals or set timeouts all over the place, because if you clutter your callback queue, you can have the same problem, right? Those operations will happen before processing click events or other redraw events. But what you can do is throttle your request. Now, this is going to take a little bit longer, but request animation frame is a way to process the queue in a little different way. We're going to say, JavaScript, when you're ready to repaint the browser, do this thing. When you're ready to repaint what I'm looking at, do this thing. So this has a few advantages over a set timeout or a set interval. And those are, one, I don't need to clear that interval later. Two, I know it's throttled to at minimum 60 frames per second, because that's as fast as your browser will repaint. Yeah. Now, it's kind of ugly though, right? Like, I don't love the way that I would have to put a callback into this, pass a callback into this function, and it messes with the way I think about my scope. So a good design pattern would be to put that inside of a promise instead. You guys familiar with promises? I hope you guys are, because they're great. In this case, I'm able to reshape that roll till critical async into a promise but I still use the same animation frame async, right? So, great. We can format our code how we want. We can prevent thread blocking. But how can we actually multi-thread? Because none of this is actually multi-threaded. We're actually still just using the same paradigm as with the stack and the queue. And yes, it is possible. You've probably done it. But it's not real multi-threading in all cases. It's multiprocessing or parallel computing. This is kind of a gimme, right? XHR, AJAX, Axios, or fetch. It's all a method of calling a function and processing something on someone else's computer. That's the positives of that is that they don't block the main thread at all, right? You can send that request out. It uploads it asynchronously, and when it comes back, it shoves its response into your callback queue. They use another core, so it is technically multi-threading. Those are the positives. And now, obviously, there are drawbacks to this. One, if the data is to be processed is large, you're going to have to upload all of that data and wait for a response. It's not ideal. May not be feasible because it's not going to give you back that response more quickly enough. And second, it doesn't scale, right? Like you're operating on your own or on your server, right? You're not operating on the distributed system of the JavaScript engine on each of your clients. And it's pretty easy, especially if you use the fetch API, which is great. It's actually the same as Axios, but you can post something, a very long process, post a body to it, and then handle it with a promise, right? There's another option, which is the GPU. Now, this isn't the GPU in JavaScript. Provides to you a subset of JavaScript operations, which means you can pass something, you can pass a 2D array to it. Here, I'll give you this example. And this is actually a specific library that I've played around with and not used in production. But it's cool, because what it does is you're able to pass a small operation to it. It can operate on that thread. You can pass it 2 arrays, and it can go super fast because it's actually converting those into textures which are being processed with WebGL, which can make it incredibly fast. Doesn't require network request. It's actually multi-threading because you're using multiple cores within your GPU. But there are negatives, right? Like I said, you can only use a subset of your JavaScript toolkit. It still also blocks the main thread, and compatibility is quite limited. Although it does have this particular library does have a fallback to the standard, then it'll run it in JavaScript. But then it'll block your main thread for even longer, right? Which is what we want to get away from. So our next thing, the next true multi-threading in JavaScript is web workers. You drop off the work and get a call when it's done. Full JavaScript, you can do it all, even network requests. Local, it runs on the local machine, although you do have to specify where to download the worker JavaScript file from. And it's true parallelism. It doesn't block the main thread, and its responses get added to your callback queue. Negatives, none. They're excellent, use them today. Actually, well, one, it doesn't have access to the DOM, so you can't make operations on your actual document. And wait, another, and that is you kind of have to manage yourself if the message coming back is the message that I sent, but that's neither here nor there. It's actually multi-threading. And it's supported on virtually every browser as long as you discount IE from, now in the past. And it's a pretty simple syntax. We declare a new worker, give it its URL, you pass it a payload, and in this case I ask for a button. So this is actually going to run the same synchronous code that I used to roll that synchronous D20. And in a web worker, not only is it able to go much faster, it doesn't block my thread. So you could see how much more quickly I was able to process that many iterations. So our takes a pretty simple API, uses a self object. This is the entirety of the code in the worker.js. Self on message equals row critical sync, and then we self post message. Yes, it mixes lowercase and camel casing. I don't know why. It's already accepted as the standard, but it does that. Post message is camel case, and on message is lowercase. Sorry, I didn't write it. I would have made it uniform, and it would have all been Pascal case, so you could have. In reality, you guys are all using a front-end framework. It's pretty difficult to actually overflow the stack. Milliseconds of blocking may be better than unmaintainable code, and you're probably not doing anything complex enough or dealing with a large enough data set to show a delay. But that doesn't mean you can't write non-blocking code. Thanks. Yeah, questions?
Yes, you're posting the slides, right?
Yeah, I'll put the slides in the Slack. Yeah.
We're going to go back after this, after the event too, and the organizer will make sure that everything gets in the Slack from the other two presenters as well.
Any other questions?